Every time you ask ChatGPT a question, roughly 175 billion numbers get multiplied together to guess a single word. Not the answer. One word. Then it does the whole thing again for the next word. And the next. The most expensive autocomplete in human history, and I'm going to show you exactly what those numbers are doing. Here's the part nobody tells you. There is no magic in there. No spark of understanding. No tiny digital brain having thoughts. It's matrix multiplication and a calculus trick from the 1600s, run at a scale that would make your laptop burst into flames. Let me prove it. We're going to build this thing from one neuron up to ChatGPT, and I promise you'll understand the math by the end without even noticing you learned it. Let's start with the atom of the whole operation. A single neuron. Despite the dramatic biological name, a neuron is one of the most underwhelming things in mathematics. It takes some inputs, multiplies each one by a number called a weight, adds them all up, adds one more number called a bias, and then runs the result through a function. That's the entire neuron. If neurons unionized, this would be their job description. The weights are the interesting bit. Think of each weight as a little dial. Turn it up, and that particular input matters more. Turn it down, and the neuron stops caring about that input entirely. A neuron is basically a tiny opinionated committee member who has decided exactly how much to weigh each piece of evidence, and the bias is its baseline mood before anyone even shows up. Then there's the activation function, and the most famous one is so dumb it's almost insulting. It's called ReLU, and here's the complete mathematical definition. If the number is negative, output 0. Otherwise, leave it alone. That's it. That's the breakthrough that helped launch the deep learning revolution. Decades of neuroscience, billions in research, and the winning move was if it's negative, just make it 0. Somewhere a PhD student is weeping. With this one neuron, we can already do something. Picture a flat plane covered in dots, some red, some blue. A single neuron can draw one straight line and say blue on this side, red on that side. Useful. For exactly as long as your data is willing to be separated by a single straight line. Which brings us to the problem. Some data is not that cooperative. The classic example is XOR. Red dots in two opposite corners, blue dots in the other two. Go ahead, try to separate those with one straight line. You can't. Watch our single neuron attempt it. It tilts the line one way, loses half the reds, tilts it the other way, loses half the blues. At some point it just gives up and goes home. One neuron, one line. That is its entire skill set, and XOR has humbled it completely. So we do what humans always do when one of something fails. We get a bunch more of them and stack them in layers. The input goes into the first layer of neurons, their outputs feed into the next layer, and so on. And something remarkable happens. Each layer doesn't just draw lines, it bends the entire space. Picture the flat plane of dots getting stretched, folded, and warped like taffy. After a few folds, those impossible to separate dots line up so neatly that a single straight line can slice right through them. That's the real mental image I want you to keep. A neural network is a space folding machine. It takes a problem that's tangled in the original space and crumples reality until the answer becomes obvious. Origami, but for data, and with significantly more electricity. Now, doing this neuron by neuron would take forever, so mathematicians did what they always do when something is tedious. They hid it inside a matrix and pretended it was elegant. Here's the secret. An entire layer of neurons, all those weights, all those sums, is just one operation. Multiply your input vector by a weight matrix, then add a bias vector. Written down, it's y equals w times x plus b. That clean little equation is doing the work of thousands of neurons at once. And this is genuinely all ChatGPT does. When you type a word, it gets turned into a list of numbers, a vector. GPT uses vectors with hundreds of dimensions, so the word cat might be 768 numbers that, individually, mean nothing to you and everything to the machine. That vector gets multiplied by a giant matrix, transformed, fed forward, multiplied again, millions of times. Everything the model does is this one operation over and over until it runs out of money. Here's a fun bit of perspective. Economists have been multiplying matrices and fitting straight lines for decades. They call it linear regression, and not one of them produced a trillion-dollar company. The entire trick of modern AI was taking that same boring math and doing it 96 layers deep with a billion dials. Same ingredients. Wildly different dinner. But I've skipped the most important question. Where do all those weights come from? Nobody sits down and types in 175 billion numbers by hand. The network learns them. And learning, mathematically, is just a very organized form of being wrong on purpose. It starts with a loss function, a single number that measures how badly the network screwed up. Show it a picture of a cat, it confidently says fire truck. The loss is enormous. Get it right, the loss is small. The whole goal of training is to make that number as small as possible. The network is a student whose only motivation is lowering its own embarrassment. Now imagine the loss as a landscape. The horizontal directions are all the weights you could choose, and the height is how wrong you are. Somewhere down in this terrain is a valley, the combination of weights that makes the network least wrong. We need to get there, but this landscape has hundreds of billions of dimensions, so we can't just look at a map. We're hiking blindfolded. The trick is the gradient. The gradient is a piece of calculus that, at any point, tells you which direction is steepest uphill, and if you know which way is up, you just walk the other way. Take a step downhill. Recompute. Step again. This is gradient descent, and it's exactly like a ball rolling down a hill, except the hill is the size of the universe and occasionally shaped like a saddle, a cliff, or, in my experience training these things, a hot tub the ball happily sits in forever. The size of each step is the learning rate, and it's a delicate thing. Too big, and your ball leaps clear over the valley and bounces off the opposite wall like a caffeinated pinball. Too small, and it inches downhill so slowly your grandchildren will inherit the training job. Picking the learning rate is less a science and more a vibe, which is a sentence that should terrify you about the entire AI industry. Okay, but here's where it gets genuinely clever. To do gradient descent, you need the gradient for every single weight, which way to nudge all 175 billion dials. Computing that naively would take roughly until the heat death of the sun. The solution is backpropagation, and at its heart is the chain rule, a calculus identity from the 1600s that fits on a napkin. Here's the intuition. The output is wrong by some amount. Backpropagation takes that error and flows it backward through the network, layer by layer, asking at each step, how much did you contribute to this mistake? The error signal ripples from the final layer back toward the input, assigning blame to every weight along the way. It's blame flowing downhill through an organization, the executives at the output making one bad call, and the responsibility somehow trickling all the way down to the interns near the input layer. The chain rule is just very efficient corporate accountability. And that 4-line calculus trick, the kind you half-slept through in your second semester, is the engine of every AI system on Earth. Newton and Leibniz invented it to describe falling apples. Now it writes your emails. So why deep learning? Depth just means stacking many of these layers, and the payoff is abstraction. The early layers learn embarrassingly simple things. In an image network, Layer 1 detects edges, little lines. Layer 2 combines edges into textures and corners. Layer 3 assembles those into shapes, and eventually, deeper layers recognize entire faces. Nobody told it to do this. It discovered the hierarchy on its own, by being wrong a few billion times and rolling downhill. There's even a theorem, the universal approximation theorem, that says a network with just one hidden layer can, in principle, represent any function at all. Which sounds amazing until you realize it might need a layer wider than the observable universe. So we go deep instead of wide. Depth is just the practical way to be powerful without renting every atom in existence. Which finally brings us to ChatGPT and the architecture that runs it. The transformer. The transformer's headline feature is called attention, and the idea is beautifully human. When you read "the cat sat on the mat because it was tired," your brain instantly knows it means the cat, not the mat. Attention lets the model do the same thing. For every word, it decides which other words to pay attention to. Mechanically, this is, brace yourself, a weighted average. Each word compares itself to every other word using dot products. Those scores get squashed into nice probabilities by a function called softmax, and the result is a blend that emphasizes the relevant words. The model also gets positional encoding, a clever set of numbers tacked on so it knows word order, because dog bites man and man bites dog are very different newspapers. And the entire training goal, the thing $100 billion of compute was spent on, is this: guess the next word. That's it. Show it the whole internet. Hide the next word. Make it predict. Measure the loss. Roll downhill. Repeat. GPT-4 does this with an architecture so vast it's hard to picture, trained on essentially everything humans have ever written down. The grandest intelligence project of our era is a fancy game of fill in the blank. So here's the punchline. Everything you just saw, the neurons, the space folding, the matrices, the ball rolling downhill, the blame flowing backward, the attention, that's the whole thing. There's no understanding in there, no consciousness, no little ghost in the machine pondering your prompt. It's matrix multiplication and calculus, the same math sitting in a high school textbook, run 175 billion numbers at a time. The technology is genuinely revolutionary. The math, almost insultingly, is not. The only new ingredient was the audacity to do it at unimaginable scale. If this finally made the black box feel a little less mysterious, subscribe to Improper Integral for more visual math and science, where we fold space, roll balls downhill, and refuse to call any of it magic.